We've elected to use a professional level Zoom subscription that will allow us to continue providing parallel sessions on Tuesday as we have done in the past. Due to this change in format, we are in need of some new batch of volunteers. We need a group of online hosts who will initiate the online sessions for the moderators, monitor for technical glitches, delegate control to the speakers, and keep everyone else on mute. Training will be provided. If you're interested in doing this, please contact Paul Sloan. His contact information is also available on the website. The scholarship auction is also going virtual, which luckily we were already planning to do before COVID happened, so at least we were prepared for that one. The auction will be available throughout the entire summer seminar and will end after the final session. Our scholarship committee is currently collecting items for the auction to support our scholarship program, but we're still trying to figure out how to store and then distribute those items. So if you do have something to donate, please send a picture and a description to Jin Chiu, our scholarship committee chair. Don't forget that some of the coolest items are the ones that are homemade, so don't be afraid to try out those craft skills to support the future generations of engineers. Sponsorship options for summer seminar will also open July 1st. We've significantly modified the structure for this year due to going virtual, and now there's only one level of sponsorship. This is going to be $500, which includes website recognition, on-screen recognitions between technical sessions, half-page digital online program booklet ad, a digital program listing, and 4 free registrations. We've also figured out a way to include our vendors in our virtual event and still have a few spots available for those. This will include website recognition, on-screen recognition between technical sessions, half-page online vendor program ad, a 5-minute commercial before a technical session with time after this session to meet with people, and 1 free registration for, this will all be for $400. Additional details for sponsors and vendors will be available on our website once registration has opened. One final announcement, this year we have added a new appointed position to the board, a past president representative who was nominated by our group of past presidents. This non-voting position will help advise the board and take on special projects throughout the year. I'm excited to announce that Kenny Voorhees has accepted this position for 2020. We will be including this position and hope to add an elected voting member position to the board for 2021. I also want to take this opportunity to thank all of our committee chairs who have continued to volunteer their time as we modify everyone's initial plans from the beginning of the year to accommodate the current circumstances. Special thanks to Chris Maddox for making the change to set up our monthly meetings as virtual events. I'm proud to be the president of Georgia ITE this year as our group continues to rise up to the challenge of offering a very similar schedule of events despite them being virtual, especially our large conference. We are one of the first large ITE conferences to be conducted virtually and will be a reference point for all future events. I'm pretty confident that our current planning is setting the bar quite high. Thank you to all the board members who have put up with my endless emails and text messages to run down the rabbit holes of options for making decisions. And finally, I want to thank all of you, our members, who have shown us a lot of support as we make these difficult decisions. We really appreciate you and your understanding as we evaluate how to offer events to ensure the safety of everyone involved. That's all I have for announcements. Let's turn over to our sponsor for today's webinar, MH Corbin.
Hey everyone. First I want to say, Kate, you've done an amazing job. This is definitely not the easiest time frame to step into. So I really applaud you, Chris, all the other officers, board members. Y'all have done a great job. This is Shannon Fain. I think I know pretty much everyone here, but to let you know what we do at MH Corbin, for more than 30 years, we've been leading providers of ITS systems that are highly customizable. That's something we pride ourselves on. We've partnered with transportation professionals around the globe, and what we really strive to do is to increase the efficiency of their networks, keep motorists and other users, different modes, aware of any issues or traffic safety, wide range of options there, And to go along with that, our latest groundbreaking product, the one that really, really impressed me, is the Connect ITS. And what that is a small device that sits out in the field, and it collects data from other ITS devices. And those devices don't have to be the same brand, same company. So those devices come into the Connect ITS, where then a communication is sent out, or an action. So that could range from simply activating a flashing beacon on site, to notifying TMC staff, notifying connected vehicles, and so on. So it's really a device that brings together all of the other ITS devices out there, completely devoid of any certain brand or type. So it's very compatible. I won't take up any more time. We have a good session coming up here. Definitely some interesting data. But if you want to learn more, shoot me an email, sfain@mhcorbin.com. And I think most of y'all have my number. Give me a call, shoot me a text, 404-771-7479. Thanks, everyone.
Thanks, Shannon. So I'm going to introduce our May webinar speakers. We've got 3 GDOT employees from the Office of Traffic Operations that are going to talk about the impacts of COVID-19 and the data around that. First up, we're going to have Aaron Steed. Aaron graduated from Georgia Tech in 2014. Shortly after, he began working for the Georgia Department of Transportation in the signal permitting section at the TMC. For 5 years, he gained a vast amount of experience reviewing signal plans and TE studies. In 2018, Aaron received his PE license. In September of 2019, he became the State Safety Engineering Supervisor and currently assists with managing the state safety program. Next up, we'll have Ben Lemke, who graduated with a BS in Civil Engineering from Georgia Tech. Following a couple years of construction management, he transitioned to traffic engineering and has been working with the GDOT Traffic Operations Group for 1.5 years. His current role is supervisor for Georgia's Regional Traffic Operations Program, RTOP. And then third, we will have Robert Baker Jr. Robert is a graduate of Georgia Southern University with a bachelor's degree in civil engineering technology. He has 15 years experience in the transportation engineering field here in the Atlanta metro area in both the private and public sectors. He currently serves as traffic operations manager for the Georgia Department of Transportation, TMC. Take it away, guys.
Thanks, Kate. I'm going to go ahead and share my screen. All right, good afternoon, everyone. My name is Aaron Steed. I'm the State Safety Engineering Supervisor at the TMC. Today, I'm going to be presenting on the effects of COVID-19 on traffic safety data. So the purpose of this presentation and this study that we did was just to examine the impacts that COVID-19 has had on the amount of fatal crashes, as well as its impact on the amount of injury crashes. We also wanted to know how has COVID-19 impacted crashes overall, as well as its impact on crash type. So just to provide a brief timeline on how we got here, I think we all saw globally the impacts of coronavirus starting in January, and the end of January, the World Health Organization declared a global emergency. By the end of February, we had our first US death reported on February 29th, 2020. And on March 2nd, we had the first confirmed case reported in Georgia. On March 9th, we had a confirmed case in the Fulton County school system that resulted in the closure of all Fulton County schools. And by March 16th, many businesses, including GDOT, began telework operations. By March 18th, Governor Kemp had officially closed all schools statewide. On April 2nd, the governor issued a statewide shelter-in-place order to help slow the spread of COVID-19. That order lasted 22 days, and on April 24th, businesses such as gyms and fitness centers, barbershops, nail salons, those type of businesses were able to reopen. And by the 27th, movie theaters and restaurants were able to open again for dine-in services. We felt that this was the best official timestamp as far as trying to identify a window of time that we wanted to collect data on and look at the impacts. We understand that a lot of the shelter-in-place type activities had already begun around mid-March, with schools being closed and businesses converting over to telework operations, but we felt that the official shelter-in-place order was the best period of time to study. So if we look at the table here, we kind of focus on the left side of the table first. What we wanted to do was take the same 3-week window as the shelter in place and examine that, just a month prior. So we chose March 2nd through the 23rd, and then we compared that to the same time frame in 2019. And what we saw was that we actually had an increase in fatal crashes of 16% and a 3% increase in serious injury crashes. Overall, we did see a 17% reduction across all crashes. And just keep in mind that out of this 3-week window, there's about a week's worth of data where people had already started to convert over to those shelter-in-place type activities. So we feel like that's a contributing factor as to why we saw even a 17% reduction, even though technically it was before the shelter-in-place order. If we examine the right side of the table for our actual shelter-in-place time frame, we saw significant reductions across all crash severity types, with a 16% reduction in fatal crashes and a 32% reduction in serious injury crashes. Overall, we did see a 59% reduction in all crashes. Based on our cab code scale, it was estimated that these reductions resulted in a cost reduction of $66 million per day. I do want to note that although there's a 59% reduction in the amount of property damage only crashes, there are some agencies that have stated that for property damage only crashes, they would not be sending out any police officers to conduct crash reports. So we understand that the number of property damage only crashes is most likely underreported, but due to the significant amount of reductions we saw across even injury crashes, we're still confident that there's a significant amount of reduction in property damage only crashes also. And then also one more thing that I'd like to point out is that these agencies, they have 30 days to get their reports uploaded into the crash reporting system. And with the shelter in place ending on April 24th and us collecting this data towards the end of May, we were right outside of that 30-day window. So it is possible that just due to the operations of some agencies, they may not be meeting that 30-day requirement. So there could still be a number of crash reports across all severity types that have not been uploaded into the system yet. So we do understand that. This is a table just showing the reductions based on crash type. We saw a significant amount of reductions across all crash types. Most notably, we saw a 72% reduction in rear end type crashes during the shelter in place. And I do want to note that we only saw a 28% reduction in not a collision with motor vehicle type crashes. Typically, those crashes are going to consist of your roadway departures. The reason that was interesting to us is because as we look at this crash density map of all the crashes in the state during the shelter in place, the impacts are most noticeable in the metro Atlanta area. And trying to explain that, one of the things that we came up with as a potential explanation is that in the metro Atlanta area, you have a lot more signalized intersections and just intersections in general. And if you factor in that signalized intersections, we typically see a high amount of rear end crashes. And we take into account that there was a 72% reduction in rear end crashes and a 57% reduction in angle crashes. That could help explain why we see most of the impacts are more noticeable in the metro Atlanta area. And then conversely, with our roadway departures typically occurring in the southern or more rural parts of the state, with there only being a 28% reduction in those type of crashes, that could help explain why the impacts are not as noticeable in other regions of the state outside of the metro Atlanta area. This is just a line graph showing the total amount of crashes during this period in relation to 2019. As you can see, early in March, we were actually trending higher than the 2019 data. But as we hit some of those timelines in mid-March where businesses started to close and schools started to close, you see the reduction in crashes, and then you see that continue through the shelter in place. This is just another crash density map showing just the injury and the fatal crashes, again, most noticeable in the metro Atlanta area. This is a line graph showing the fatal crashes in comparison to 19. Fatal crashes can be a more chaotic event than other crash severities. So that's why the line graphs kind of appear to be all over the place. But you'll notice that, again, we were trending higher early in March and really throughout March, but we were able to see that 16% reduction during the shelter in place. So ultimately, the shelter in place ended up kind of balancing the data. And for the total time period between early March through the shelter in place towards mid to late April, the total amount of fatalities ended up being about the same. And then again, just a line graph showing injury crashes. Again, you see the trend in early March, and then we hit middle March, and then the shelter in place, and you see those reductions. So in conclusion, we saw a 16% reduction in fatal crashes, a 57% reduction across all injury crashes, and a 59% reduction in crashes overall. Some of the challenges with the data, we do understand that there's an underreporting of property damage only crashes, though we do think there's still a significant amount of reduction in those type of crashes. And then we also understand that agencies, it's possible that some of them have not been able to get all of their reports uploaded yet, and that's for all crash types and crash severities. This is something that we're going to continue to monitor so that we can understand what the impacts have been immediately after the shelter in place. And then it's something that we'll just want to keep in mind to know what the impacts have been on the crash data for the year 2020 as a whole. That is going to conclude my presentation. I will turn the presentation over to Ben. Thank you.
Thanks, Aaron. Let me pull mine up. Okay, good afternoon. My name is Ben Lemke. As Kate said, I work in the GDOT Regional Traffic Operations Program. If you're not familiar with RTOP, it's a signal timing program that's focused on the major commuter routes into, out of, and around the metro area. So following the traffic reductions we were seeing for COVID-19, we began using the ATSPM website to analyze the traffic pattern changes. If you're not familiar with ATSPM, it's a signal performance reporting tool that relies on field detector data. I've listed the link here because it is a public-facing site that anybody can access. So we use ATSPM to analyze the volumes we were seeing against those same locations at the 2019 volumes to quantify the impact that COVID-19 was having on vehicle traffic. So to capture a high-level analysis of the Metro Atlanta region as a whole, we chose a handful of representative corridors, and on each of those corridors, we chose a representative intersection that has good count data and is representative of the corridor volumes. And so you can see on the map here, as well as the corresponding table, those are the corridors and intersections chosen for this analysis. So using the ATSPM volumes, our team created this graph, which shows an average reduction we were seeing across those representative intersections. And although the graph doesn't show back that far, the volume reductions begin in early to mid-March, and that's when our teams began implementing lower cycle lengths and free plan operations. So as new announcements and restrictions came out, these plans, as well as our traffic responsive systems, need close monitoring and adjusting. I've highlighted the week here on this graph where it appears that the volumes begin to plateau. That was back in early April. And since then, they've been steadily climbing. However, they're still not back to what were the normal volumes. So when you take a look at that same data broken out by corridor, typically we were seeing less impact as you move further away from Metro Atlanta. And this trend is likely due to a couple of reasons. First being that the urban corridors tend to be more commuter dependent, and with more people working from home, there's much less commuter traffic, as well as the event and business closures brought in less traffic from the suburbs. So if you look at State Route 6, Thornton Road, that's the top graph, the reductions only peaked around 20% in comparison to over 50 to 60% on Northside Drive and Moreland Avenue. So in addition to Thornton Road being further away from the metro area, it has a high truck volume, which freight appeared to be far less impacted. And as you can see, all of the corridors did tend to follow the same curve and plateau around the same time. So each of our timing systems were impacted differently, and overall, as expected, our traffic responsive systems tended to handle the pattern changes better. But once reductions got around 30%, that's when traffic responsive tended to have trouble selecting the right plans, or it would bounce from plan to plan. For anybody not familiar with traffic responsive, it's a signal timing system that can be programmed for a signal group where the controller will automatically make plan changes according to the real-time detector data that it's getting. Therefore, this was a perfect test for those types of systems, since they're intended to be able to automatically respond to random and unexpected traffic patterns. So we were able to implement lower cycle length and free operations as there was less mainline demand, and this better served pedestrians and side streets. And it was the perfect opportunity to evaluate these plans, since typically they would fall to a lower priority. So in general, our lower cycle lengths varied between 100 to 140 seconds. And in many cases, the timing teams were able to fine tune existing low cycle length plans. But there was also many cases, especially for off-peak hours and weekends, when lower plans needed to be created. And then in those locations where there were very low vehicle volumes, as well as random arrival patterns throughout the day, and there's good presence detection, we were able to implement free operation. However, as I mentioned before, all of these approaches required daily volume monitoring and fine-tuning, especially early on. So ATSPM was extremely helpful for developing the new time of day schedules. This is an example of how some of the timing teams would use these volume reports that they could pull from ATSPM. In this example, you can see that the normal midday volumes, which is the top graph, look very similar to the PM volume, or sorry, the peak volumes during late March in the bottom graph. And so this is an example of how those teams would use the daily volumes provided by ATSPM to create new time of day plans. As I mentioned earlier, the traffic responsive systems tended to handle the changes well, but there were common adjustments that were needed. So action thresholds, they're typically created to call in peak plans when an increasing traffic pattern is detected. And that's so the plans get called in early enough. So since the traffic pattern still occurred, but the peak plans weren't warranted, the threshold programming needed to be adjusted in many cases. And as I mentioned before, in some cases, corridor volumes got so low that lower cycle length plans needed to be created. And since the intent is for these traffic responsive systems to be able to respond to these changes, the goal during this time of fine tuning was not only for it to be able to handle the low vehicle volumes, but to be able to adjust back as volumes increase to what will be the new normal. So this slide shows a couple of great examples of how our timing teams would show how the traffic responsive systems were handling the traffic pattern changes. So both of these are back from March, and on each of these graphs, the blue line shows the average cycle length that the traffic responsive systems called in, and that was for early March, whereas the green line shows the average cycle length plan that was called in for the latter half of March after the volume reductions. As you can see, the plans followed the same curve, the same peak times and midday times. And then on the graph on the left, you can see that during the midday, the cycle lengths appear to bottom out. And that might be an instance where the timing team would look at creating a lower cycle length if there was one warranted there. So we were able to use the Mark I website to see how the lower volumes impacted our performance metrics. If you're unfamiliar with Mark I, it's another public-facing website. I've listed the link here. And it's a monthly reporting website that reports on our signal metrics, and they can be analyzed down to our contractual levels or specific corridors, or even down to a specific intersection level. So this is a snapshot of our April performance metrics as compared to the first quarter of 2020. So many of these are what we would expect. There was a substantial decrease on throughput and spillbacks. And with the lower cycle lengths and heavily reduced volumes, split failures also significantly decreased. One thing that was negatively impacted was progression ratios. So a progression ratio, that's the ratio of arrival on green percentage as compared to the percentage of green time for that given phase. So it's a measure of efficiency at an intersection. So as you can imagine, as you have more random arrival patterns and plans being constantly adjusted, they weren't quite as efficient as they would be during normal, more predictable times. So a few of the lessons learned was one, truck volumes did appear to increase, especially early on, as it was most likely due to the restocking efforts for depleted consumer goods. And then construction activity also appeared to increase, which makes sense. Most likely contractors taking advantage of the decrease in traffic, especially during the peak hours. And as I mentioned earlier, traffic reductions tended to be greater in urban areas where there's less local traffic. And another issue that I didn't really anticipate was our detector diagnostics. So our vehicle detectors are programmed to send watchdog alerts when there's unusual calls signal that there's a malfunction. So we receive a bad detector alert when certain unexpected events occur, such as an unusually high amount of force-offs, or if there's load detection counts. So this snapshot here is an example of a few detectors that showed a lot of alerts throughout the month of March until the patterns could be adjusted for lower volume conditions. And that concludes my portion of the presentation. I'll now hand it over to Robert.
Thanks, Ben. Let me get my PowerPoint up. Yeah, so my name is Robert Baker. I'm one of the traffic operation managers. I'm directly oversee the 5-1 incident management group on the traffic ops floor at the TMC. Here I'm going to speak about the COVID-19 experience from the 5-1 incident management group as well as from the ITS group. 5-1 incident management, we're a
real
group
quick,
of,
I don't think your screen is sharing yet. Sorry to interrupt.
okay.
Let's see.
Okay, all right.
There we go.
Okay, all right, great.
Better. Thank you.
Okay, so the 5-1 incident management group, we basically track all the incidents that take place on our interstate and state routes. We try to make sure the flow of information is going smoothly between our operators and all the first responders on the field so that we can clear the roadways as quickly and safely as possible. Our operators utilize our various ITS devices to proactively identify incidents that take place on the roadway through our scanning our CCTV cameras and looking at data in our navigative platform from our various detector stations that detect volume and speed. We utilize our ramp meters and variable speed limit signs to try to limit congestion in the areas where we see incidents taking place. We also use our dynamic message signs to put out information to the traveling public and to make them aware of whatever incidents are taking place on the roadway. So first, we're going to delve into some of the numbers that we were tracking during this COVID-19 shutdown period. Here we chose 7 locations in the metro area along our interstate routes and tracked that data for 3 weeks over the COVID shutdown period. We came up with weekly averages for those 3 weeks and compared those volume averages to the same weeks in 2019. You can see on the charts in the last row, there's some locations where we're seeing significant reductions in volume. One notable location was Georgia 400, where we were seeing decreases of 44%, consistently across the 3 charts. And also locations such as I-20 westbound and I-20 eastbound near MLK. We think that we saw the most reduction in those locations because the travelers who take those routes are typically local to the metro area. There are not a lot of pass or through traffic. So as you saw through the news reports, people strictly adhere to the stay-at-home orders, and that probably explains why we saw the most significant decreases along those routes in the data that we collected. And here in this chart, it gives a overall of the data from all the 7 locations, basically showing the volume reductions over time, starting from mid-March to early May. You see April 6th shows the negative 40% reduction in volume. That was during the time that, offices were shut down, schools were closed, mandatory stay-at-home orders were given. And after that, you saw the volume slowly increase. Well, the reduction slowly increased over time, well, decreased over time, as those restrictions were taken away. So here's some RIDIS data. Basically, RIDIS takes the data from our navigator platform with from our various ITS devices, and the blue line basically showing the 2019 data, and the volume shown here on the connector southbound, and the orange line basically shows the data for the current year. And you see how significantly the volume dropped for this 24-hour period. This next slide shows for that same location, I-75 southbound, it shows the reduction in speed as a result of the reduction in the volume. And again, the orange line is the current data, and shows that the speed increased to 50 miles an hour for the PM rush, where it typically would be 20 miles an hour on a typical PM rush hour period. Same for the connector northbound. We see the reduction in volume here, comparing last year's blue line to this year's orange line. And we saw the same trend. Speed vastly increased to 60 miles an hour as compared to what it typically would be around 30 miles per hour on typical PM rush hour day. This is a graphic from our partners at HERE, basically showing the travel time index, comparing what it would be on a typical rush hour day in 2019. And to the right, you'll see our more current snapshot in March 16th, showing our current day congestion. And that is for the AM peak period. And here is the same slide for the PM peak period. So from the ops floor standpoint, we were tasked by GDOT upper management 2 weeks before the governor shut down all offices. We were tasked with coming up with a contingency plan of how we would basically maintain our incident management operations if we were given the order to work from home. It was a collaborative effort between the 511 Incident Management Group, GDOT IT, Hero First Responders, the D3 Ops Center, as well as CERTA, and with RTOP. We wanted to make sure that we maintain the critical capability of being able to manage incidents taking place on the roadway to, ensure, efficient and safe travel to the public, even during this, the government shutdown. We still want to be able to dispatch the first responders, which means we wanted to make sure that we had our critical radio and telephone equipment to be at our operators' disposal when they would be working from home. We still wanted them to have dependable access to our GDOT network so they can access files and also have access to our Navigator application as well. So this meant equipping them with laptops that we had to procure for each operator to make sure they can take those laptops home and be able to make phone calls on a laptop, be able to enter in Navigator data when they're managing incidents. Also, they had to have the radio equipment so they could be able to talk to the first responders in the field and be able to get on the phone and call our partnering first responders, such as our police, and be able to communicate with them and keep the flow of information going back and forth. Some milestones we met, we were able to have 50% of our staff work from home a week prior to the GDOT office closures. So we easily had 100% of people working from home once those orders were given. We maintained access to all our ITS devices through making sure the laptops had access to the Navigator platform. We were working with CERTA. We were able to keep the express lane systems operating and the reversals going as usual, even though everybody's working from home. And we maintained relatively good communication with our hero first responders and our champ units, as well as our local agency partners out in the field. So this graph shows the trend of calls comparing the current year in blue to our past year in red. Typically, our operators on the floor would receive from 5,000 to 10,000 calls on any given week. But definitely due to the decrease in travelers, we see a significant dip in callers during this COVID-19 period. Here's a graphic showing the number of incidents that we managed since we started working remotely from home. And this is the day when remote work started, going into the day of, when we, they had the stay-at-home orders, and as you see that restrictions started to ease up, we started to see slight increases in incidents that we managed. And when we say incidents, we mean anything from motorists who are experiencing flat tires to, major tractor trailer crashes that take place on the interstates and state routes. So you see, as we go towards the current day, the number of incidents that we manage on a daily slowly start to creep back up, still well below what we would typically handle on a daily basis. Here is a even better graphic to take into account. Here, the blue line at the top is basically showing the number of incidents on a month-to-month, well, on a week-to-week basis. This is starting from the 44th week of last year on to the current 19th week, which is mid-May. And you can see that we took a big dip during the 15th week. That would most likely correspond with the stay-at-home order. And we slowly started to increase in incidents that we managed as time went on towards the current day. In this graphic here, we're basically showing our hero response time. This is a time when we're able to be notified of incidents that take place on the roadway, and we're able to reach out to Hero and have them go out and respond on scene to the incident. As you can see, from June of last year up until May 20 of this year, these response times are pretty much consistent. And this is due to our ability to still maintain good communication with our hero first responders out in the field, even during this COVID-19 pandemic. So that, to me, I see that as a good success, because our ability to respond to incidents out in the field didn't waver at all. The roadway clearance times vary because the type of incidents we will respond to vary. Some, would take more, have fatalities involved and take more cleanup efforts to actually clear it from the roadway. So those vary, but we definitely kept our response time consistent throughout this COVID-19 period. And that concludes my slides. I guess I'll pass it back on to.
Thanks, Robert. I'll take it back. I want to thank you all on behalf of Georgia ITE for presenting today. I'm sure you're getting standing ovations in 100 different locations right now, so congratulations. Real quick, there is a chat section, so if you have questions, please enter your questions in there. We're about to take those in a moment. And also, we have a link for a survey to complete for your PDH, for your roll call, pretty much. So if you would, please access the chat and complete that survey. And let us know if you have any questions. I see we've gotten a few so far. And Aaron, I think these ones go for you first. Did you end up looking at crash data by mode, crashes that involve pedestrians or bikes?
Yeah, so for the presentation's sake, we did not include crashes by mode. We did pull the crash data, so I know that for the shelter in place period, or April specifically, there was a 36% reduction in crashes involving pedestrians from 2019 to April of 2020. And then for bikes, we did not dive into that information, but that's something we can circle back on and provide an answer for.
I think another one for you is that, was there any indication that speeding became an increased factor for types of crashes due to reduced traffic on the roadways?
So we did see an increase, or we have seen an increase in speeds, but the data did not show any correlation as far as an increase in the number of fatal and injury crashes. But we could dive deeper into the data to see if, as far as like contributing factors, if speed is maybe occurring more as a contributing factor. My guess would be that it's not, but that's something we could look further into.
Well, I think unless any more questions trickle in right now, thank you again for taking the time out of your day to present. We really appreciate it, and hope y'all enjoy the rest of your day. Kate, anything else from you before we?
Nope, that's it.
All right, everybody, have a wonderful day. Thank you very much.